So now, let's talk about our inner electrons. And so inner electrons for this one is going to be completely different than the inner electrons for your chlorine, mainly because you have some F and some D orbitals. And so for this one, you're still going to be looking at your xenon. You can count the fact that you have 54 electrons in your xenon. But again, that xenon is only including everything up until this point right there. And so if you're only to drop down and say that these are all your inner electrons, you're forgetting about the fact that your 4F and your 5D, those are completed as well. And so because of that, because you have reached your 6s2 and your 6p1, that means that your F and your D from the previous levels, or your n equals 1, again here you can kind of see your n equals 1 is completely filled up. Your n equals 2 is completely filled up. Your 3s2, 3p6, and 3d10 are now completely filled up as well. So all those are inner levels. Your 4s2, your 4p6, your 4d10, as well as your 4f14 are all completely filled up, meaning the fact that your n equals 4 is completely filled. And so those are still going to be considered, again, inner electrons. Same deal when we get to our 5. So our 5s2, our 5p6, and our 5d10, all those are sitting in an inner electron or inner field because they are still, again, completely filled up, and they're probably not going to interact with anything else, again, by like reactions or anything. So this 4f14 and this 5d10 are still considered inner electrons. And so in my notes on in my slides that I posted on Blackboard, I stated the fact that it's going to be any of your noble gas configuration in any filled d orbital. I left off the f orbital because I didn't really show any real examples about those in my slides, but now I'm telling you. And so the f orbital if it's completely filled up, and the d orbital if it's completely filled up, and again you have popped out of the 5d into the 6p, all of these are considered inner electrons, where you're going to have 54 electrons from your xenon, 14 electrons from your 4f, and 10 electrons from your 5d to give a total of 78 inner electrons. And so the last thing is these valence and these outer electrons. If you take a look on your periodic table, or even just look at the fact that I have 6p1 here, you know that this thing is going to be sitting in the p block. Anything in the S block or the P block are main group elements. And so for your outer electrons, you're going to be looking for the highest n equals value, or the highest energy level. In this case would be your 6 and your 6. And so your outer electrons will include the 2 electrons from your 6s and 1 electron from your 6p in order to give you 3 outer electrons. And because this is a main group element, we know that a number of outer electrons is equal to the number of valence electrons. And so for that, we know that we're going to have 6s2 and 6p1 will give us our 3 outer and valence electrons. And so this next example is not too different or complicated. And again, I kind of skipped this because hopefully you understand how I'm going about and getting all this information here. But the main reason why I wanted to show you something about chromium is because this is one of the ones that I refer to as funky electronic configuration. And by funky, what I mean is if you look at something like chromium, and again, chromium and molybdenum, the MO, will have the same kind of idea. In addition to that, your copper and your copper, gold, and silver will also have the same kind of concept, but it's a little bit different. And so if we take a look here, the whole idea of what I call half-filled and completely filled shells or orbitals are much more stable than partially filled. And so if we look at this, we have a 4s2 orbital, which is completely filled. Here we have 3d4, but as you should notice by now, your total number of electrons you can fit into a d orbital is 10. And so basically, this is 4/10 of the way from being filled, or it's partially filled. But if you look at the idea of half-filled, this is 1 electron away from being 5/10 or halfway filled. And so what what chromium does, and again, chromium and molybdenum both do the same thing. The only difference is in molybdenum, this would be 5s2, 4d4. But in both of these cases, one of these electrons from your s orbital actually jumps ship and goes over to the d orbital. And in this situation, as soon as this happens, you are now looking at 4s1 3d5. And so if you take a look at how these things are filled up now, 1 electron out of 2 electrons, or your S, is halfway filled. In this one, you have 5 electrons out of 10 total, or 5/10, or halfway filled. In this situation, your chromium written in this form, it's going to be much more stable than it's ever going to be in this 4s2 3d4. So technically, this will never exist. This does not exist. As soon as it kind of comes into this form, actually, it theoretically comes into this form, then again, this electron immediately jumps over into the d orbital, and the electronic configuration, the only correct electronic configuration for chromium, is going to be your argon 4s1 3d5. And so please note, the same exact thing happens with molybdenum, and very similar thing happens with your copper, your silver, and your gold. And so in those cases, you'll actually be looking at something like 4s2 3d9. And so in that case, 1 electron still leaves the s orbital and goes into your d orbital, and you'd end up with 4s1 3d10. And this last one I kind of want to talk, I'm sorry, I forgot about the inner electrons. So for this one, your inner electrons, again, is going to be not too complicated. It's going to be the number of electrons inside your argon. And so this is actually going to be slightly different than the previous ones when we talk about outer and valence electrons. Chromium is a transition metal, and so therefore it is sitting in that D block. And so for transition metals, the number of outer electrons and the number of valence electrons is not equal to each other. So the number of valence electrons is the total of your outer electrons plus any d electrons that are inside of that configuration. Your valence electrons, your outer electrons are only going to be the electrons in the highest energy level. And so for this one, you have your 18 inner electrons, but your outer electrons. So outer electrons, again, the electrons in the highest energy level, or in this case, 4, not your 3d, because 3 is less than 4. And so your 4s1 is going to be the only outer electron in this situation. And in addition to that, when we talk about valence electrons, it's going to include your outer electrons plus any d orbitals, any electrons in the d orbital. So this, you're actually going to be looking at your 4s1 plus the 3d5 to give you a total of 6 valence electrons.